Section 2 focuses on independence and whether or not two are independent. So, since we talked about this, what you need is the outcome or of what is not going to affect your event. Um, and for dependent, the ability will change on it happening. So, for example, an event would be me drawing a card from the deck and placing it, and then so those independent become replacing the card. Thing about is like a die rolling a 4 and rolling on 3. You can't roll a 4. So, dependent would and then draw. Remember, second or drawing one. We're going to use is take our observed frequencies for our two different variables, and we arrange them into rows and columns. So R stands for our rows and C stands for our columns. Where the two intersect is going to be called a cell. So this is a cell, okay? This would be a cell, all right? So let's look at a picture. So for this one, it says we have a contingency table that shows the results of 2,200 adults that classified their favorite way to eat ice cream. So that's 1, 2, 3, 4, 5 columns, and their gender, male or female. So 2 rows. Okay. The other thing that we like to find with this is our marginal frequency. Okay. So what is marginal frequency? All right, so this is when you're going to sum up your rows or your columns. So let's go ahead and do that right now. We're going to add up each of our columns and each of our rows, okay? So if we do that, we are going to get, for this first one here, 1,010. And then 628, 384, 44, and 134. All right, and now let's go ahead and do the rows. So I'm getting 1,200 and 1,000. And that's going to give me 2,200 total. Oh my gosh. Okay, let me see if I can move this over just a teeny tiny bit. I think I just need to make this guy smaller because did that work? There's such a delay when I use my recording software, and okay, there we go. All right, perfect. Okay, so we're going to come back to this. We're going to do our first example with this problem, but first, let's run through a few more things. Okay, so what we are going to do is we are going to first find the expected frequency for each cell. And so to do that, we're going to be using this formula. So how you get your answer is you're going to take the sum of that respective row multiplied by the sum of that respective column for that cell, and then divide that by your total sample size. So let me actually, I'm going to copy this onto the other slide so I have it. Now I'm gonna see if I can, oh, I probably can't delete this, can I? Yeah, I'm probably not. Okay. Put it on top of it. Okay, awesome. Okay. All right, there we go. Okay, so I'm gonna actually do this on the next slide just because there's quite a bit of writing. So we are going to use this formula, all right? And so for instance, we're gonna start with the first row, first column. So that's this 600 right here, okay? So we represent that with E11. So we're gonna start E11, okay? So if I look back to my chart, we need the sum of that row. So the sum of that row is 1200, okay? And the sum of the column is 1010. And we're gonna divide that by our 2200, okay? So 12,000 times 1010 divided by 2200. And we're gonna get about 550.91, okay? And then we're gonna do the same thing with the first row, second column. So now what I'm looking at is, I'm looking at this right here, okay? So we're gonna have 1200 times 628, okay? Divide that by 2200. Then we're gonna do the 204 spot, so 1200 divided or multiplied by 384 divided by 2200. And then we're gonna do this one and then this one, okay? So we have to do all of these problems. So you probably want to pause so you can do this as well. 628. Okay. All right. So what I'm going to do now is I'm just going to write the answers down because otherwise we will be here for a while. So hopefully you actually did pause so that you could do this. So E13 is about 209.45. E14. And if you need to see these equations written out, this example is in your textbook. 73.09. Okay, now I need to do the second row. So this time, like for instance, if I was going to do the second row, come on. Okay, so for the second row, the females that like ice cream in cups, we're talking about this 410 value, so we're going to do 1000 times 1010 divided by 2200. So this time my first number in all those problems would be 1000. Okay, so let's finish typing these out. Okay, there we go. So E no, that's not typing. What? Okay. All right, well, this is going to be interesting. So it's no longer typing, so I'm gonna use my pen to write out the rest of the answers. Okay, so E21 is about 459.09. E22, I got about 285.45. Okay. All right, so let's go through a few more facts before we finish up this example. All right, so we are going to be using, Clark, can you not? We're going to be using the chi-squared independence test. And so what our test is going to do, it's going to determine if the occurrence of one of the variables is affecting the second variable's probability. So some things to keep in mind with this is you have to obtain your observed frequencies by using a random sample, and your expected frequency has to be greater than or equal to 5 in order for this to work. All right, so this formula looks familiar. We talked about this one in 10.1. And so we're going to be using the same thing. And you are remembering that this is a right-tail test. Now, our degrees of freedom is going to be a little bit different this time. So our degrees of freedom, to calculate that, we're going to take the rows and subtract 1, multiplied by the columns and subtract 1. And this is going to come into play because essentially with our contingency table, we are going to be setting up matrices. Now, if you're freaking out a little bit about matrices, the only part that you need to worry about is plugging into the calculator. So all you have to do is type numbers in. It's not bad, I promise. Okay, so steps. First, make sure that your expected frequency is at least 5. You're going to identify the claim. The claim is typically going to be the events are independent, and then the alternative would be not independent, so dependent. Make sure you identify your level of alpha. That's going to help you determine your critical chi-squared value. Degrees of freedom. This is new thing. Find your critical value using the table in the back of the book. That helps you determine your rejection region. And again, these are right-tailed. So what does that mean? It means this would be my rejection region, anything greater than that critical value. Then you're going to find that standardized test statistic. And from there, you can make the decision whether or not you are going to reject your null or fail to reject. And then you're going to write your final summarizing sentence. Okay? All right, so let's think back to our ice cream example. So for the ice cream example, it's saying that gender and your favorite way to eat ice cream are dependent, okay? So what we have here is we have a null hypothesis saying that adults' favorite way to eat ice cream is independent of gender. And then our alternative would be essentially the same thing, except instead of independent, we're going to say there. Oh, did I spell independent right? Independent. No, I did not. Wow, that's bad. That's really bad. Independent. Okay, so it's going to be the same thing, except we're going to replace the word independent with dependent. Okay, so I'm just going to write blah 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 dependent. Okay. All right, so what we're going to do is we are going to fill in this chart right here. Doop, 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 doop. Come on, go to the next thing. Okay, so what we're going to do is we're going to take the observed values that we had from the chart. Okay, so for instance, we had 600, 288, 204, 24. So that was my first row. And then we had the, and 84. And then we had 410, 340, 180, 20, and 50. Okay, so then this column is going to be the expected values that we found. So 550.91, 342.55, 209.45, 24, 73.09, 459.09, 285.45, 174.55, 20, and 60.91. Okay, so now what I want you to do is I want you to pause and I want you to fill in the rest of this chart. Okay, so hopefully you got this. And so for this first one, I got 40.09, negative 50.55. I'm just subtracting observed minus expected. Negative 5.45, 0, 10.91, negative 49.09, 54.55, 5.45, 0, negative 10.91. All right, then the next column, I'm squaring that. Okay. And then finally, for this last column, I am dividing the column to the left by the expected value in that particular row. Okay, so once you do that, you're going to add everything up in this column. Okay, and when you add everything up in that column, you are going to get your chi-squared value standardized test statistic of okay, here we go. All right, so we're getting about 32.630. Okay, so I should have probably found my critical value first, right? Okay, so let's go ahead and do that. So for my degrees of freedom, what I'm going to do is take my rows, subtract 1, multiplied by my columns, subtract 1. So in essence, I'm getting 1 times 4, which gives me 4 degrees of freedom. And then if I look in the chart on the back of the book, I'm going to get a critical value of 13.277. Okay, so the question is, if this is 13.277, and this is my rejection region, is 32.630 to the right of 13? And the answer is yes. So what does that tell me? That tells me that I'm going to reject. Okay, so what does that mean? That means that at the 1% significance level, there is enough evidence to conclude that adults' favorite way to eat ice cream and gender are dependent. All right. So what I want you to do now is there's another example here. I want you to run through that example And then I want you to watch the second video that I've posted, and the second video is going to teach you how to do this in the calculator. Okay.